Ohm's law was given by German physicist Georg Simon Ohm. It states the relationship between current, resistance, and voltage across an electrical circuit. This relationship between current I, voltage V, and resistance R was given by famous German scientist Georg Simon Ohm in 1827. He found conducting his experiment that the product of the current flowing through the conductor and the resistance of the conductor determines the voltage drop over that conductor in the circuit. Ohm's law definition. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it, provided all physical conditions and temperatures remain constant. Hence, according to Ohm's law, the current flowing through the conductor is directly proportional to the voltage across the circuit. Example: V is proportional to I. Thus, as Ohm's law provides the basic relation between the voltage applied and current through the conductor, it is considered as the basic law which helps us in dealing electric circuit. Ohm's law states that the current follows a linear relationship with voltage. Ohm's law explanation. Ohm's law is one of the fundamental laws of electrostatics which state that the voltage across any conductor is directly proportional to the current flowing in that conductor. We can define this condition as V is proportional to I, removing the proportionality sign, V equals Ri, where R is the proportionality constant and is called the resistance of the material. The resistance of the material is calculated as R equals V divided by I. Resistance is measured in ohms. It is denoted by the symbol omega. Ohm's law formula. Under the condition that all physical parameters and temperatures remain constant, Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it. Ohm's law is stated as V is proportional to I, or V equals I into R, where R is the constant of proportionality known as resistance, V is the voltage applied, and I is the current flowing through the electrical circuit. Voltage, current, and resistance. An electric circuit is formed when a conductive path is created to allow electric charge to continuously move. This continuous movement of electric charge through the conductors of a circuit is called a current, and it is often referred to in terms of flow, just like the flow of a liquid through a hollow pipe. The force motivating charge carriers to flow in a circuit is called voltage. Voltage is a specific measure of potential energy that is always relative between 2 points. When we speak of a certain amount of voltage being present in a circuit, we are referring to the measurement of how much potential energy exists to move charge carriers from one particular point in that circuit to another particular point. Without reference to 2 particular points, the term voltage has no meaning. Current tends to move through the conductors with some degree of friction, or opposition to motion. This opposition to motion is more properly called resistance. The amount of current in a circuit depends on the amount of voltage and the amount of resistance in the circuit to oppose current flow. Just like voltage, resistance is a quantity relative between 2 points. For this reason, the quantities of voltage and resistance are often stated as being between or across 2 points in a circuit.